Hello and welcome to the Machine Learning Podcast, the podcast about going from idea to delivery with machine learning. Data powers machine learning, but poor data quality is the largest impediment to effective ML today. Galileo is a collaborative data bench for data scientists building natural language processing models to programmatically inspect, fix, and track their data across the ML workflow, from pre-training to post-training and post-production. No more Excel sheets or ad hoc Python scripts. Get meaningful gains in your model performance fast, dramatically reduce data labeling and procurement costs while seeing 10x faster ML iterations. Galileo is offering listeners of the Machine Learning Podcast a free 30-day trial and a 30% discount on the product thereafter. This offer is available until August 31st, so go to themachinelearningpodcast.com/Galileo and request a demo today. Do you wish you could use artificial intelligence to drive your business the way big tech does, but don't have a money printer? Graft is a cloud-native platform that aims to make the AI of the 1% accessible to the 99%. Wield the most advanced techniques for unlocking the value of data, including text, images, video, audio, and graphs. No machine learning skills required, no team to hire, and no infrastructure to build or maintain. For more information on Graft or to schedule a demo, go to themachinelearningpodcast.com/graft, that's Graft, and tell them Tobias sent you.
Your host is Tobias Macey, and today I'm interviewing Tuhin Srivastava about Baseten, an ML application builder for data science and machine learning teams. So Tuhin, can you start by introducing yourself?
Yeah, hey, I'm Tuhin. I'm the CEO and one of the co-founders of Baseten. I have a background in machine learning, have been founded a couple of companies, have been working on Baseten since 2019.
And do you remember how you first got started working in the space of machine learning?
In 2011, actually, I was working in finance, pretty unhappy in my job. I studied electrical engineering in college and done a bunch of information theory. I was looking to figure out how to get out of finance, and I came across this opportunity to go do research with a neurologist in Basten who was trying to figure out how they can use non-invasive biomarkers to track the progression of neuromuscular disease. So I went over there, joined his lab company, and we ended up doing a bunch of really cool stuff and around predicting onset of disease and how that disease progressed. He published a bunch of papers, worked on a small company with regards to it, and I was off to the races.
And so in terms of what you're building at Baseten, can you give a bit of an overview about what you're focused on and some of the story behind how it came to be and why you decided that that was a problem that you wanted to spend your time and energy on?
Baseten is a machine learning application builder for data science and machine learning teams. I think the best way for users to think about Baseten is kind of like a toolkit to get your models out of notebooks and into value. We started Baseten really out of a pain point that we saw for ourselves, is that we were working in machine learning teams at very, very small companies where we didn't necessarily have all the resources we needed to bring those models to market. So, as to make it a bit more concrete, we were working at a startup called Gumroad that was working on fraud detection and content moderation. And as a machine learning engineer myself, it took me about 3 to 4 weeks to get this great data set together and come up with my first model. I realized really, really quickly after that was that I'd have to become a full stack engineer to be able to actually get this model to value for the business, because we just didn't have the resources to figure out how to deploy that model, how to build the backend to support that model, how to build the internal tools that operate off the output of the model. And so, I think back in 2012 to 2015, I and our team went and basically learned that skill set. So in the absence of those resources, and that was great for me, frankly, but pretty horrible as an investment for the company. And, fast forward to 2018 and 2019, and we're talking to a bunch of our friends who, run machine learning teams and do machine learning at larger companies or at, mid-sized companies. And what we realized was that the results from machine learning efforts and initiatives haven't really lived up to all the hype. We went pretty deep on what we found, at least, was that there's all these great tools in the machine learning operations, like the MLOps space, where they're making it really easy to train your models, experiment with your models, and figure out how to get those models, behind some sort of API. What we found was missing was that once that model was behind some API, you'd still need a whole full stack team, which is exactly the problem that we ran into. And so, we kind of conditioned upon a set of use cases and tried to see if we could abstract out that toolkit that kind of productized that skill set that I went and learned, or our team went and learned back in the day. And that's really, what Baseten is today.
In terms of the problems that you're solving, you made it pretty clear that, there's the initial step of I've got a model and I can put an API in front of it, but then how do you actually build the whole application around it? And so in terms of the solution for that problem, I'm wondering if you could speak to the type of user that you're focused on addressing to fill that requirement, and some of the types of organizations that might rely on that capability rather than maybe having their own in-house team to productionize these applications around these models, or sort of what the typical flow is from I've got a model and I've got a prototype built with this, full stack app builder in the form of Baseten, and then now I actually want to, bring the feature set even further.
The target users for Baseten are data scientists and machine learning engineers. For us, we've done a lot of work on figuring out where these users and teams sit. And for us, it's usually, they work at companies or at teams where they don't have support of a machine learning platform team. For us, that makes it super easy because there's only, like 10 or 15 companies in the world with proper machine learning platform teams. Like the way I would kind of characterize it is, you're part of a scrappy team, you have a machine learnable problem, you know what that first version of that model is going to look like. Maybe you have somewhere between 1 and 10 data scientists on your team, but you don't necessarily have, a complete platform team built out to support that data science function. In terms of, like where they are from like a sophistication perspective, I think that's a good question. I think, for us, it's kind of what I said, like they need to have a machine learning problem. Like what's a really bad target for us is that if a data engineer picks up Baseten, because, what we find is that, you're still focused on getting that data in the right form, which is a big problem in itself. You need to kind of be past that stage and more in the, I have a model. In terms of like the requirements from those users, we make one assumption of our user, which is, Python. And we lean very, very heavily into that assumption. We find Python to be very, very powerful, but what we try to abstract away is all the infrastructure required to work with Python and to give you a set of other tools that allow you to leverage Python to solve real business problems. So, I'm just going to, maybe this is not the right time for it, but I can just jump into like how we do that, if that's helpful. Firstly, we have kind of like 3 pillars to Baseten. First one is around model deployment. So, you have a model sitting in your notebook somewhere. Baseten has a little SDK, you can call from your Python notebook or your Python shell that wraps most types of models. So that's scikit-learn, TensorFlow, Keras, so on and so forth. And, within really like a few minutes, you can have a model deployed behind an API and ready to go. But that's really where the value of Baseten starts to come. We think deployment's actually a commodity. We're not super interested in being a machine learning deployment company. That's integration cost for us. We just happen to have an added benefit there. The next step, though, is that you need to build some sort of API that sits around that model. So, the inputs and outputs of a model don't really map to the business requirements. You need to do some pre-processing and post-processing. You need to write that data somewhere. You need to combine it with some other data. And so we kind of give you this thing that looks like AWS Lambda or GCP, where you can, write Python code that interacts with that model in Baseten. And all of a sudden, you've gone from a model in your notebook to a model behind an API to a model with some business logic around it behind an API. And then the third pillar is kind of like that more front-end application building part of it, which is, you have a model. Let's go back to that fraud example, is that your model says, hey, I am 90% sure that this is fraud, great. But when your model says 40% sure, 50% sure it's fraud, you want a human to be able to review that. And so Baseten kind of gives you a low-code UI builder to be able to interact with that business logic that I described earlier, but also put together these UIs quite quickly.
As far as the overall process for being able to build these full stack applications with Baseten, as you said, it gives you, a lot of useful tools that are all tightly integrated to be able to manage that end-to-end flow of I've got a model, now I need to build the app around it. In the absence of Baseten, what are some of the strategies and utilities and kind of development patterns that teams have built up to be able to solve that problem, and some of the pain points that they're experiencing as far as trying to integrate all of those components on their own?
what folks have come up with is kind of like two solutions. One is to hire consulting teams, especially when you go to larger companies. They just hire application building teams to sit on top of these ML models. We think that's really bad. I understand the need for it, but the fact that these machine learning teams can be so far removed from the products that they're powering, I think actually leads to worse outcomes overall. That's approach one. Approach two is just to stitch together a bunch of different solutions. So, like what we've seen is, you would deploy your model with like SageMaker or something on GCP's Vertex or Selden. You then go and spin up a Flask application and run that in AWS, or you will use AWS Lambda or GCP Cloud Functions to interact with that model. And then you pipe that to some database, and then you'll again either rely on a consulting team or a different product engineering team to build with that data, or you'll use something like Streamlit or Retool to sit on top of that data. Now, I think that is probably the scrappiest, most productive teams that are able to do that. Most teams just get stuck. Data scientists don't really know infrastructure that well. They know infrastructure around models. They shouldn't need to know infrastructure. This is not what their core skill set is. And so as a result, what happens is that, these models just end up somewhere running on local notebooks and don't really get really beyond that. I think the other approach, which I think the more successful companies have taken, is to really start to work with machine learning platform team. But as I said, that's really a champagne problem where you're doing really well when you have the resources to be able to put together a machine learning platform team.
In terms of the actual process of running a model in the context of an application, beyond just being able to wire together the UI or build the API, what are some of the sort of core technical requirements that are needed to be able to actually support that model as it's operating and ensure that you're able to scale it as usage grows, or ensure that you're able to monitor it or manage the integration of the API endpoints into the actual model execution and any sort of supporting storage or the other sort of technical components that are required just to be able to say, I have a model, I have an application, and everything is running and happy?
I feel like you just outlined everything yourself there. But in terms of without Baseten, the truth is you need like a DevOps team, right? You need folks who know how to configure servers, how to manage storage. Oftentimes models can be quite big. So even unpicking them can take up too much memory. And so I think without Baseten, you end up requiring to do a lot of the same sort of DevOps engineering that you would require with a traditional web app at scale or traditional API at scale, but you have to do it a bit earlier because you run into these memory requirements a bit earlier than you traditionally would. I think, what's interesting is that machine learning models kind of also bring in like a second set of considerations around performance of that model. I'd say like that performance of that model is probabilistic and not deterministic, which is interesting. And, that just brings a whole new set of monitoring constraints around that model. It's like, okay, is this model running? Great. How fast is it running? Fantastic. Now, the harder questions to answer is like, is this model doing the thing that we want it to do? And the answer to that is probabilistic, brings up a whole new set of challenges. With Baseten, what we try to do is try to abstract all that stuff away. So, our goal is to make, the easy things super easy, yet make the hard things still possible. And so for us, what that means is that machine learning teams and data scientists can, deploy a model with a few lines of code, and the default is sensible. You don't need to think about scaling stuff up because we have an auto scaling strategy for your model. Our models don't go down. And when they do, we have code to take care of that for you. And we provide you monitoring dashboards and health dashboards to be able to look at that. That being said, as an engineer myself and someone who's struggled over the years with, dealing with stuff like Heroku, it can get really frustrating when a lot of these platforms just abstract so much away that you actually can't configure anything that you want at all. So we actually provide the knobs necessary for you to be able to change things underneath you if you need more compute, if you need a GPU behind it. Baseten gives you those knobs, but the default is sensible and good enough. And we've thought about kind of like stuff like auto scaling and load balancing, but you don't need to think about that as a data science and machine learning team.
You mentioned a couple of other projects that are in sort of a neighboring space of making it easier for a machine learning engineer or a data science team to be able to go from, I have a hypothesis, I will build a model, and now I just want to be able to wire this up to, prototype something. So you mentioned Streamlit. I know that there's also the Hex platform. There are a few other projects and platforms and systems that are available in the ecosystem to reduce the barrier to entry for somebody who's very heavy in the sort of statistical and machine learning capacity to say, I just want to put this in front of somebody to do something with it. And I'm wondering if you can just give your kind of characterization of the space and maybe some broad categorization of how these tools might be used and applied and where Baseten fits in that overall spectrum.
From my perspective, at least, the emergence of all these tools has been truly fantastic. It is amazing that we are creating these tools to make this thing that's actually very difficult a lot easier. I say that, I am a big fan of Streamlit and I'm a big fan of Hex. I feel like, just by design, they're more suited to like BI use cases as opposed to operational machine learning use cases. And so, what I mean by that is that what we're going after is these real human loop workflows where we're trying to build the tooling that allows you to combine humans with machine learning models and make decisions. That is, Baseten's bread and butter, like fraud detection, content moderation, where there's a model making a decision and you need a human to work with that model to kind of make a better decision. I'd say that, even beyond Streamlit and Hex, I think products like Retool have just been fantastic and really, more than anything, just destigmatizing this idea of we're at a point now with software engineering that we can abstract away a lot of these things, especially if you condition on like a certain set of use cases. I guess like Retool's big maybe realization was that, hey, all internal tools actually have like 7 or 8 primitives. In other ways, they have, they have a button, they have a form, they have maybe some BI to them. And so I think like, I'm really excited by all these UI builders that have come up, and whether they come in the form of Streamlit, which is very much like write Python, get a visual app, or Hex, which is kind of Streamlit plus the drag and drop ability to make into a narrative and making it really easy to tell a narrative, or Retool, which is like, hey, you can just build internal tools, very internal, great. I'd say Baseten definitely fits into one side of that, which is very much that we make it easy for you to build these user-facing applications. But I think we're also focused on the back end, which I'd say some of these other projects or companies aren't so focused on today. And then maybe they will probably go there at some point. But it's like, with the Retool, you still need to set up your own back end or set up your own database that you can query against, but it very much is the front end. Like with Baseten, we allow you to build APIs. I think that, I don't know if there's that many faster ways to execute a blob of Python code behind an API than Baseten. It's literally pasting it into something, like building an orchestration graph in a point and click manner, so no YAML required, and you have an API ready to go. But really what that allows us to do, and the integration with the model side allows us to do, is be a lot more focused on workflows as opposed to maybe kind of single-use applications or single-use dashboards.
Digging into the Baseten platform itself, can you talk through some of the implementation and architecture and custom engineering that you've had to build to be able to support this workflow of take a model, build an application around it, and put it into production?
I think a few things. So the first thing, I'll start from the model building side. And so like the first thing we did was like, built this cool way to like SDK in Python that you call with your Python client with one line, you can deploy a model. And what we're doing there is actually inspecting your environment, looking kind of like what are the requirements you need, and spinning up a Kubernetes cluster somewhere to run that code, and then give you an API to access that Kubernetes cluster. Our goal here was to make it so that the amount of custom code per se necessary to be able to build that for the user was as minimal as possible. The second part of Baseten is even more interesting, right? Where it's like very much like Replit, where we are running user provided code. So in some isolated environment. And that has all sorts of security concerns, as you might imagine. But really, again, what we're doing here is that, you provide us some blob of Python code. We have some pretty intuitive way to assemble that. But, again, and you give us requirements to TXT, which might be the requirements to run that code. And again, we go and create a cluster somewhere with that isolated environment, run your code, and provide you the interface to do that. Like, we have to go through a few rewrites of that, because I think the actual core problem of running that code was difficult from an infrastructure perspective. But The harder problem was like, what is the user experience for writing code on base 10? And what does that look like? And so like what we wanted to do was build a way that you could write code locally. You could push to base 10 as opposed to have to write your code in base 10. And I think while the infrastructure behind it is definitely very impressive, like I think what's more impressive about what we built is kind of like that user interface to writing code so that, you feel like it fits into your developer workflow. I think skipping over to the front end side of things, what's been really interested is like, how do you build the drag and drop tool so that, your data scientists can build a UI without having to know JavaScript. And, that's not purely reactive or display UI, it's stuff with event handlers. So what are the abstractions required so you can, bind a button to run some code without knowing any JavaScript? That was actually harder than I thought it'd be. I thought this is, sounds hard. In practice, like we can probably, put something out there pretty quickly. Turns out it took us 2 or 3 different rewrites to get it right. But, like our problems really have, or like the solutions we've come up with have really ranged from really deep infrastructure problems of like, how do you run, these models or these blobs of code somewhere and create the API in a performant way, to security, to how do you isolate users' codes from one another so they can't access it. So how do you protect users from users and how do you protect base 10 from users? I think these are hard security problems that, spent way too many hours smashing our head against walls for. But, I think we've come up with good solutions. And to the more, what are the abstractions required or what is the framework required so a data scientist can build UI without knowing any JavaScript and complex UI. And I think, the range of problems there is actually quite complex, and tying them all together in a performant manner so it doesn't feel like one jump with mess, that's been even harder, which is like, the UI and the user flow, if you may.
And you mentioned that you went through a few different iterations of how to tackle this problem. I'm wondering if you can talk through some of the ways that the original design and goals of the project have changed and evolved since you first started working on it to bring you to where you are today.
I'd say like when we started the company at the end of 2019, we weren't really sure where we sat in terms of what we required of our users. And this actually put us in a really bad spot. So like, it led us astray for a second where, for a long time we were like, the user knows Python, but maybe they don't need to know Python or they need to know a little bit of Python. I think what we realized maybe like a year into the project was that actually code's amazing and like we shouldn't try to hide code away. Like we are building for a very technical audience who is pretty proficient with Python and we should lean really heavily into that. And I think that's probably when that was like a big, almost like paradigm shift for us when we stopped trying to, build for the lowest common denominator, if you may, and instead just we're like, our user knows Python really well. They can even think about infrastructure. Maybe they don't know the language of infrastructure, but they can't even think about these things. Let's lean into that. So that changed even just like how you wrote code, how you orchestrated, running code, what the APIs look like. Even for the UI builder, like what did we require from the user to be able to bind data to a table? Is it okay if they have to write a snippet of code? And I think once we leaned into that, a lot of those, ideas became a lot clearer. And, I kind of like leaned pretty heavily on one of our developers, Soren, he does a lot of open source work and he's the primary maintainer of the React Monaco library, which we use very heavily. But talking to him, I remember asking him, like, how do you decide what should be part of the project and what shouldn't? And he talked about, really early defining the philosophy and the user of your project and, being really, really crystal clear around kind of what your philosophy, what your utility function is. For us, that came a bit later than I would have hoped. But once we had that utility function in place, like it became really, really easy to not only prioritize features, but like design the software and the underlying abstractions.
Because of the fact that you do allow for users to submit arbitrary code to customize the behavior of their backend, that always brings in a lot of interesting challenges around security and performance and making sure that somebody doesn't either try to bring your platform down or do it inadvertently because they accidentally enter into an infinite loop. And I'm just curious how you handle some of those additional complexities of being able to appropriately sandbox the user's code and then maybe also ensure that you provide some limitations and constraints to make sure that you don't end up in these infinite loops or accidental explosion of performance consumption.
I can't speak to a lot of that beyond my pay grade and have taken it far away from me. I can say that, it's kind of managed in 3 different stages. One was from a security perspective, which was that, how do we protect users from other users? How do we protect users from base 10? And how do we protect base 10 from users? We have a lot of customers who give us quite a lot of sensitive data. And, it is very important for us to be able to solve these. And these are the existential problems for Baseten if we get them wrong, frankly. I think what's again a bit more interesting is the more usability side of it. It's like, how do we protect users from doing, things that will make them end up in in bad states or in infinite loops. I think this all comes down to having sensible timeouts, knowing when to stop running code. I think probably most importantly, making it really easy to do the right thing as opposed to, and making it hard to do the wrong thing. And I think, we've spent a lot of time to ensure that, if you do get into a bad state with things like infinite loops, it's likely because, you kind of did it on purpose, opposed to got there by accident. So again, just to reiterate, from the infrastructure perspective, spend a lot of time just because it's so important protecting users and making sure that our current state scale, and from a usability perspective, just making it really easy to do the right thing.
Predabase is a low-code ML platform without low-code limits. Built on top of their open-source foundations of Ludwig and Horovod, their platform allows you to train state-of-the-art ML and deep learning models on your datasets at scale. The Predabase platform works on text, images, tabular, audio, and multimodal data using their novel compositional model architecture. They allow users to operationalize models on top of the modern data stack through REST and PQL, an extension of SQL that puts predictive power in the hands of data practitioners. Go to themachinelearningpodcast.com/Predabase today to learn more. That's PREDIBASE.
As far as the overall design and interaction patterns for people who are building an application using Base 10, I'm wondering what the kind of discovery and design process looked like for figuring out this is the maybe not necessarily optimal workflow, but this is a workflow that is understandable and accessible for our target audience, and some of the maybe initial false starts, we'll say, that you ran into as you were starting to say, okay, this is what we think is the right way to go about it, but now we're actually going to put this in front of some of our early design partners, get some feedback, and then figure out, oh, actually, that was not the right way to do it. What led you to the current approach of breaking it into the different kind of core kind of concepts and base components that you ended up with now?
I think we started from the user stories, and we kind of thought about what are all the things the user needs to do. And again, it really helps being, a perceived user of your own product, because, we thought about it that way. Okay, we want to deploy a model, we want to build APIs, and we want to build front ends. And then, we kind of took it one step lower. Okay, we want to build APIs in Python. We don't want to think about AWS. We don't want to think about Docker. And I think we really decided to start from that top level and kept breaking it down to, more and more lower level stories until it kind of matched into, okay, how would this work for a given product? So what we did for a long time was that we had these 2 or 3 different use cases. We'd basically every week or two, we'd have our abstractions, and then we'd basically say, how do we build this start to finish with Base 10? And then honestly, we'd test that against ourselves for a long time before it felt really right and we started building it. I'd say in terms of customers, we started working with customers probably 4 or 5 months after into building the product. Should have been sooner, for sure. I think that's one of the things to be a bit too good before we started. But as soon as we started building with customers, it became really clear what worked and what wouldn't work. And so, as an example, and I alluded to this earlier, one of the things that we didn't have before was that you were just writing code directly into this orchestration graph, and then that code would be executed. The feedback we got was, hey, how does this fit into my developer workflow? How does it fit into my local workflow? How will this work with version control? How is this going to scale? I think, all these things ended up just, changing how we thought about things and really mapping it back to the existing development workflow. To reiterate, one of the things that helped us a lot as developers and data scientists ourselves, it was really easy, at least early on, for us to find our North Star in terms of building things by just engineers are pretty harsh critics of software, as you know. And, we would just ask ourselves, does this pass the bar of something we would use? And we just kept iterating until we at least hit that. And then we started going to other design partners. And what we found was we've kind of gone through those couple of higher orders of thinking by ourselves. It just made those conversations a lot easier.
In terms of the actual process of somebody discovering base 10 and saying, I want to build an application, can you just talk through the overall workflow of, taking the model, building the application, wiring the components together, and some of the decision points and design questions that they'll need to answer as they go through that process?
So to get started, it's super easy, right? So you pip install base 10, you configure your API key, and you deploy your model. And once your model is kind of in base 10, and you can start without a model, we also give you like a set of pre-trained models. We have like a lot of Hugging Face models on base 10 that you can start to play with. But once you have that, just a couple of clicks away, you can start creating files to orchestrate using that model. We give you, for our models, for the API endpoints you're building around those models, we give you a way to test everything in line before you even have to call it with an API. We give you a way to look at like logging in line so that, you can see exactly what's happening start to finish before you have to call it somewhere else. But really the idea is that you can go honestly from I have a model to deploy a model to I have an API endpoint with some, pre-processing and post-processing code with Python. And that's ready to call from an API. And, you're off to the races. I think, once you have that API endpoint configured, really it's just going and thinking about what is the application on the front end you need to support that. It's drag and drop. You can like pick a table, you can pick a button, you can pick an image gallery, a text input. You can wire it up to those API endpoints. So you can take some input from the user, run it against a model, show the output. But really, it's a horizontal product with these 3 different pillars. And I think it's like worth saying that we have users starting at all different spots. So some people start without a model. And one of the customers we're really proud of is Patreon. And, they started with a data labeling app. So they started very much in the UI builder. But a lot of our customers don't even have UI and they just deploy the models and start building APIs around it. So it really is kind of pick your own adventure. We have a guided way, how I think about it and how I use it, which makes sense, which is, starting from your model and then building the workflow and then, the API endpoint, and then building kind of the front end applications that sit on top of the endpoints.
And the UI aspect is always interesting when you throw some sort of like design capability in front of engineers, because some of them are, very design oriented and they'll build something that makes sense. And some of them will just throw everything at the wall and say, it does what I want it to do. But then, you put it in front of an end user and they say, my goodness, what have you done? And I'm wondering if you can just talk through some of the guardrails that you've put in place to maybe prevent some of that experience of, just throwing everything on a canvas and then saying, good luck, and just helping people think about that kind of end user experience for the application that they're putting together.
There's nothing to stop you from creating a monstrosity in base 10. It's like even internally, we have some engineers who build apps. You're like, that's beautiful. And other ones are just like, what is this? But I think what's more important to us is that we just try to make it easy to do the right thing as much as possible. So I think like right now we have a very limited template, but that's a very important part of, of our roadmap, which is like creating this template of UI. If you need something to, test the inputs and outputs of your model for a vision model, we'll have a template for that. If you need something that uploads an audio file and transcribes a transcription model, we'll give you a template for that. If you need something for, content moderation workflow where you need like an inbox type view so you can look at cases, we'll give you something that looks, quite nice, at least from a design perspective, is simple enough that someone can start to build with it as a template. And I think that is like, that's a really good way to like kind of point people in the right direction. I think, a little less technical, but I think Airtable has done a fantastic job of this. We love their software, which is around, like if you want to use Airtable as a database, right? And so if you want to use it for a CRM, they give you a CRM. If you want to use it for like a recruiting CRM, they give you a recruiting CRM that you can start to play with. And I think it makes it easier. It just takes some of that burden of those design choices out of the hands of that user.
In terms of the model specifically, I'm wondering if you can talk to some of the limitations or constraints that you've had to impose as far as the size or scale or complexity of the model, or some of the types of models that work better where maybe you do well with a, vision transformer or a, natural language model, but it's more difficult to deploy a, real-time computer vision app model, just some of the ways that you think about the categories of models that people are building and deploying and some of the limitations you've had to impose to make sure that you're able to actually provide a positive experience for your end users.
Honestly, no. Like there are obviously limitations. Like if you told me that if you tried deploying DALL-E 2 on base 10, it'd be pretty difficult. But, it actually scales up pretty well. And we've seen people deploy all sorts of stuff from language models to computer vision models to simple linear regressions. Like we have pretty native support for all of that. Just as an example, there's a pretty big open source model called GPT-J with 6 billion parameters, which is kind of like an open source version of GPT-3. We were able to get that deployed to base 10, in less than an hour. So, like we do scale up pretty well. I'd say that like from like a use cases perspective, like the more real time stuff where things are very, very low latency for these large models, Baseten probably not a great fit for that. But that aside, we really are quite flexible and can handle most types of models.
The other aspect of using something like Base 10, where it's very easy and quick to get something up and running, is that a lot of people will rely on it as initial prototyping, where you say to your machine learning team, you go ahead and do what you want and tell me when you've got something that's actually going to provide value, and then we'll build around it. And for the case where, you build an application, it proves some utility, and then you say, actually, I want to invest in this further and build it into the core of our product. What are the either extension points for hooking into Base 10 to be able to add additional customizations, or the options for being able to take your Base 10 application and then export it and, customize it to fit into, whatever frameworks and tool chains you're using for product development?
Twofold answer to this question. So the optimistic version of myself would say that, we should be able to scale with our customers. And I think over time, we'll see more and more of that. That being said, there's 3 pillars to Base 10, which I've kind of said a few times now. All of them are kind of very modular. So you can kind of pick and choose which ones you want. Like this was really important to us that, hey, like maybe you already have a front end team, or you want to maybe use Retool and you're a big user of Retool at your company. Like why do you have to use Base 10? So the models have their own APIs. The API endpoints are obviously modular and have their own APIs. And the front end can be used with any backend as well. So all 3 of those aspects you can switch in and out as necessary. I think, it's a necessity for us to be successful going forward, which is that it's very, very cheap to get started with Base 10. And what that means is that you don't need to use Base 10 for everything to start with, but also there are escape hatches out of Base 10. So, you can call the different parts of Base 10 and benefit from them without having to buy into the whole platform.
Going back to the model question, one of the continuing complexities that people experience as they put their models into production is the challenge of how to monitor it, how to understand what degree of concept drift it's dealing with, when I need to retrain and redeploy the models. And I'm wondering if you can talk through some of the ways that different model types or some of the different frameworks that somebody will use to build a model will influence the integration points that are available for pulling out some of those useful model-specific metrics, and then what the sort of lifecycle management looks like for when somebody says, okay, this model has gone through enough drift that I actually need to retrain it and redeploy it, and just being able to version the models in the Base 10 environment and being able to push them up.
Yeah, so we tried monitoring out of the box. Like, frankly, it's something we haven't invested the most in right now, and we will continue to invest more in it as we go forward. I think it's really tricky. I think you alluded to it, but like you really have to condition your monitoring on the type of model. It's very, very different to model like something that's outputting a simple probability as opposed to like a big computer vision model. As we invest more in that, we're going to have to figure out which ones we are best suited. Right now, we have really, really good request level monitoring, and you can browse your outputs over time to see how they are drifting. As you go over to the next question, though, I think, like Baseten has really, really good version management with models. So, you have a model and you have a new version. It's very, very easy for you to deploy that over the top of it, to kind of have some sort of strategy where you shadow, basically run it in the background for a while. And then when you're happy, it's very, very flexible. So you can do these things. Again, like this building a horizontal tool is very difficult. We've got to pick and choose your battles. And I'd say, right, like with the monitoring stuff and the version management stuff, we are very much like, I think it's, we are still far ahead of what the industry average is, but like, we have a lot of work to do in terms of making these 2 things really tightly linked to one another.
And so for people who are using Base 10 for building out applications and experimenting with how to put their models into production, or maybe just using it as an on-ramp to experiment with machine learning as a capability before they go down the process of building their own models, what are some of the most interesting or innovative or unexpected ways that you've seen it used?
We've always had a bunch of interest from people building crypto things on top of us. It's just the state of the market. We didn't expect that. It's not something that, it's not something that we are super privy on. It's cool seeing like Baseten being used in ways that the market's evolving. I think some of the more like exciting ways is, people using it for user verification. So, we have a customer that uses it. They have a platform for children to talk to each other, and they're trying to like make sure that only children participate. And so they use it to basically run their participants through a model and try to guess the age of the person. And if they think this person's an adult, then they had, someone verify it. I think that's super cool. I think, we've had a European company use us to figure out, the optimal placement of offshore energy sources. And I think like, to me, like these are the more exciting places that, what we hope from Baseten is that we're enabling all these, kind of the long tail of use cases of machine learning, and by just lowering the cost to get things working end to end.
In your experience of building this business and exploring the different ways that people are using machine learning and the types of applications that they're building around it, what are some of the most interesting or unexpected or challenging lessons that you've learned in the process?
The expectations of software as a developer, this is an amazing thing because you have such great software to choose from. It feels like we're still so early innings there. But what it has also meant is that you truly have to build something that feels intuitive and solves a problem. And that just takes a long grind. Like the reason why I think you see so many companies, have to go and raise large amounts of venture money today is because of, people's expectations of software are higher than ever. It's something I underappreciated for sure, a couple of years ago, but, I'm realizing more and more. I think what's the most interesting thing that we've learned working on Baseten is how many ideas people have for what machine learning can do for them, right and wrong. And I think, that's what makes it so exciting to work on Baseten. It's just that, ideally we can end up empowering a whole new set of use cases that, we didn't think about.
I'm curious, what are some of the ways that you're using Baseten inside of Baseten to build Baseten?
One thing which is rare in the machine learning software tooling community today, I think there's kind of like open source products and there's some weighted biases, but there's still not that much software which is easily accessible by developers, sign up and use it. And that was really important to us. So, at the same time, we're in the business of reselling compute, right? Like you can run arbitrary code. And so, when a user signs up, we try to figure out like likelihood of this person doing malicious things as quickly as possible while trying not to, ruin that first experience. And that's a Baseten app that has a moderation queue. It posts back to Slack, the heuristics in the model, and the actions are all deployed using Baseten.
That's pretty cool. And so for people who are interested in being able to just get started with using machine learning, either with one of your pre-trained models and they just want to build an app around it and see what's possible, or they have a model and they just want to get an app up and running, what is the cases where Baseten might be the wrong choice?
I think when you're going for like super real-time use cases, like Baseten probably isn't the right choice. Like internal build today is better. We'll get there. We're just not there today. I'd say that when you have more optimization models as opposed to prediction models, Baseten's not a great choice. And then I'd say if inside companies, if you care a lot about things being on-prem, Baseten supports that, but it's more painful for us and more painful for the customer. It will be more painful than if you just use the cloud offering. So I'd say, there are three cases where Baseten is probably not, we haven't built with those things as our number one priority for where we are today. They're all possible, but higher order questions that you need to answer before using Baseten for those things.
Now that you have launched and your product is available for people to start onboarding and experimenting with, what are some of the things you have planned for the near to medium term, or any areas of focus that you're excited to dig into?
Yeah, I think the biggest one is like a tighter integration with developer workflow. So can you write code in your VS Code, and there's like a little Baseten extension that deploys it. We're going to be open sourcing a bunch of stuff we've worked on, which I'm super excited about. But right now, I think over the next 12 months, we're just really focused on getting people to value. And I think, whatever that entails, whether that means more models, where we're really investing in that, whether that means, investing in monitoring, we're really excited about that. But I think, the thing that comes to mind straight away is like, how do we get even more embedded into the developer workflow today?
Well, for anybody who wants to get in touch with you and follow along with the work that you're doing, I'll have you add your preferred contact information to the show notes. And as a final question, I'd like to get your perspective on what you see as being the biggest barrier to adoption for machine learning today.
Really just getting buy-in from other stakeholders. I think today, like, machine learning has like this dual class status of having a ton of hype around it and also having a lot of skepticism around it. And I think, what's important to adoption today, I think, is just educating people about, what's possible in state of the art, where realistically most organizations are, and what it will take for those things to converge over time. And I think, that just will require, more success stories, more failure stories, and just making it, driving down the cost data rate, which I hope we're contributing to in some way.
Absolutely. Well, thank you very much for taking the time today to join me and share the work that you've been doing at Baseten. It's definitely a very interesting platform, definitely reduces the time and energy required to invest in getting an application up and running to prove out ideas. So I appreciate all of the time and energy that you and your team have put into that, and I hope you enjoy the rest of your day.
Thank you so much. I appreciate you having me on the show.
Thank you for listening, and don't forget to check out our other shows, the Data Engineering Podcast, which covers the latest in modern data management, and Podcast.init, which covers the Python language, its community, and the innovative ways it is being used. You can visit the site at themachinelearningpodcast.com to subscribe to the show, sign up for the mailing list, and read the show notes. And if you've learned something or tried out a project from the show, then tell us about it. Email hosts at themachinelearningpodcast.com with your story. To help other people find the show, please leave a review on Apple Podcasts and tell your friends and coworkers.